Welcome to Brain Vision.
Hi everyone, so what we have today is we're given a scuba diver's air tank of volume equal to 2 cubic feet. It is initially at 20 psi and 60 degrees Fahrenheit, and we have a supply line at 120 psi and 85 degrees Fahrenheit. What we're asked to find is the final temperature and final mass in the tank when it is filled to 120 psi. So what we're going to do first is do a mass balance. So we know that just from the definition of the change in the mass, we're going to define our system as the tank. We know that the mass coming in minus the mass at the end is equal to the change in mass of the system. So we'll know that, since the tank is a system, M out is going to be 0 because there's no mass that's leaving. So M in is just going to be equal to the mass at the end minus the mass in the beginning. And what we're going to do next is do an energy balance. We know that the definition of the change in energy is the energy coming in minus the energy leaving is equal to the change in energy of the system. And what we can do is we can go ahead and say that there is no energy leaving because there's no mass that's going to be leaving, so this is going to be 0. So we know that the energy coming in is simply the mass coming in times the enthalpy coming in, which is going to be equal to the change in energy of the system, which is going to be M2U2 minus M1U1. And we can rewrite HI as Cp times Ti. So we can go ahead and say Mi Cp Ti is equal to M2, and we can write U2 and U1 as Cv T1 and Cv T2. So that's going to be Cv T2 minus M2 Cv T, that's going to be M1. There's that M1 CVT1. Now what we can do is combine this energy balance with the mass balance that we had before and plug in for Mi. And when we do that, we see that M2 minus M1 CPTI is going to be equal to M2 CVT2 minus M1 CVT1, and therefore what we can do is actually go ahead and plug in some of these values that we know. We'll know from looking at the tables that the gas constant of air is going to be, so let's just plug that in. We'll say R is going to be equal to 0.3704 psi feet cubed all over pound mass R. And then we know the specific heats at temperature, so Cp and Cv from the same table is going to be Cp is equal to 0.24 BTU over pound mass R, and Cv is going to be equal to 0.171 BTU over pound mass R, where that R is just the temperature in Rankine. So now what we can do now is solve for this initial mass, and we can say that M1 is going to be equal to P1 V over RT1. Now this is just simply rearranging the ideal gas law. And we know P1, we know the volume, we know R, and we know T1, because these are all quantities that that are all given to us, or that we have looked up in the table, and we see that M1 is equal to 0.2077 pound mass. The final mass is going to be equal to M2, which is equal to P2V over RT2. Now again, this is ideal gas law rearranged. We know final pressure, we know the volume, we know the R value, and we know T2, which is something that we are going to solve for. Right, so we know that M2 is going to be equal to 647.9 over T2. And the reason is because we know P2, V, and R, M2 and T2 are unknowns. So this is M2. Next, what we're going to do is actually go ahead and substitute this into our mass balance and energy balance combination. So recall that that combination is equal to M2 minus M1 CP equals M2 CV T2 minus M1 CV T1. Now when we plug in for these quantities, we have M2. Remember, we have M2 in terms of T2. We know M1. We know CP. We know the inlet temperature. M2 again is something that we know in terms of T2. CV we know T2 is an unknown. M1 we have solved for previously. CV is something we've looked up in the table. And T1 is something that is given to us. So if you look at this, actually, the only quantities that we don't know are M2 and T2, but we have M2 in terms of T2 with the relation that's saying M2 equals 647.9 over T2. So what this allows us to do is plug in and solve for T2, and we see that T2 is going to be equal to 709.2 R Rankine, which is equivalent to 249 degrees Fahrenheit. And that is one part of our answer. So let's go ahead and box that. Recall that our expression for T2 was actually involved M2 as well. So we know that M2 is equal to 647.9 over T2. And we can plug in for T2 and we see that M2 is equal to 0.914 pound mass. And that's our final answer.